Good morning. I am Bhargava, Assistant Professor, Department of Electronics and Communication Engineering, RMK Engineering College. Today we are going to discuss DC to DC converters. First, let me start with functions of DC to DC converters. DC to DC converter is an electronic circuit which helps in transforming DC source voltage from one level to another level. We move to types of DC to DC converters. It can be broadly classified into two types, isolated and non-isolated types. Under non-isolated types, we have three different types of converters: buck converter, boost converter, buck boost converter. Now we'll discuss each and every converter in detail. First, let us start with buck converter. Buck converter can also be referred as step-down converter, which produces lower output voltage than the applied DC input voltage. The buck converter has two operating modes depending on switches on or off. First, let us consider switches on, that is closed condition. The diode becomes reverse biased and the input voltage causes a current to flow through the inductor. This charges up the capacitor. As the charging current flows through the inductor coil, it produces a back EMF which opposes the flow of current according to Faraday's law until it reaches a steady state, creating a magnetic field around the inductor. This situation continues as long as the switch is closed. Now we'll move to the second condition, switch is off, that is open condition. The input voltage gets disconnected from the rest half of the circuit, causing the magnetic field around the inductor to collapse, inducing a reverse voltage across the inductor. This reverse voltage causes the diode to become forward biased. So the energy stored in the inductor's magnetic field forces current to continue to flow through the load in the same direction and return back through diode. If Vin is the supply voltage and on and off time for the switch are defined as T1 and T2 respectively, then the output voltage V0 can be defined as V0 equals to T1 by T1 plus T2 in product with Vin. This T1 by T1 plus T2 can be replaced with D, duty cycle. Duty cycle for buck converter can also be defined as output voltage by input voltage. The corresponding waveforms has been shown next to the circuit diagram. Now let us move to the boost converter. The boost converter is designed to increase DC voltage from lower voltage to higher voltage. That is, it adds or boosts the supply voltage, thereby increasing the available voltage at the output terminals. If we can compare boost converter with buck converter, in buck converter we had series connected switch, whereas in boost converter we use a parallel connected switch to control the output voltage. As the switch is connected in parallel with the output, electrical energy only passes through the inductor to the load when the switch is off, that is open condition. When the switch is on, closed, electrical energy from the supply voltage passes through the inductor and switch and back to the supply voltage again. As a result, switch creates a short circuit to the output. This increases the current flowing through the inductor as it has a shorter inner path to travel back to the supply. Meanwhile, diode becomes reverse biased as its anode is connected to the ground via the switch. When the switch is off, open, the input supply is now connected to the output via the series connected inductor and diode. As the inductor field decreases, the induced energy stored in the inductor is pushed to the output by Vin through the forward biased diode. This results in the induced voltage across the inductor reverses and adds to the voltage of the supply Vin. That is, it becomes Vin plus VL. Its corresponding waveforms is presented in the slide. Next we move to buck boost converter. The buck boost converter is a combination of buck converter and the boost converter that produces an inverted output voltage. This output voltage can be either greater or lesser than the applied input voltage. All it depends on the duty cycle. The circuit operation can be divided into two modes. In mode 1, switch is turned on, and in mode 2, switch is off. In mode 1, while switch is turned on, the diode becomes reverse biased. The input current which rises flows through inductor and switch. Whereas in mode 2, the current which was flowing through inductor in the mode 1 would now flow through inductor, capacitor, diode and load. In this mode, the energy stored in the inductor is transferred to the load and the inductor current falls until switch is turned on again in the next cycle. Its corresponding waveforms is presented here. Here we have three different waveforms. The first one, it is VD, voltage across diode. Second, it is IL, which is indicating the inductor current. And the last one is diode current, which is given as ID. Let's move to applications of the converters. It can be used in power supply design, SMPS, switched mode power supplies, battery chargers, electric vehicles, in brakes especially. Thank you.